Assalamualaikum. Myself Sayyid Usama and my roll number is 21DE09. Here I am going to discuss the DSP Lab 12. In task 1 we are giving the systems y of n and other values with the initial conditions and the input, and then we compute the system response y of n for 20 sampling. Following code will be used. Here you can see the code of this task 1, in which we are designing the analog filters, and then we convert the digital filter using bilinear transformations, and then we plot the magnitude and phase response, and then we also create a new figure with phase response, and then we convert the phase to degrees. Here you can see the output of this task 1, the phase response to Butterworth low pass filter. Here you can see the output of this task 1. In task 2 we have given our transfer functions depicting of DSP system, and then we are determine the impulse response and step response and system response if the input is given as x of n is equal to 0.25 raised to power n and u and step response. Here we are going to discuss the code in which we determine the impulse response and then step response, and then we plot the system response if the input is given, and then we plotting the system. Here you can see the output of this task 2, impulse response, step response and system response. In task 3 we are giving the transfer functions, and then we plot the poles and zeros, and here you can see the output of this. Here you can see the graph of this task, frequency response, and now you can see the poles and zeros of this task 3. Here you can see the task 5 of this lab 12, in which we have a given system, digital system, and then the given system we are doing a sampling rate of, and then we determine the frequency response. First we define the system coefficients, and then we set the sampling rate, and then we compute the frequency response, and after this we are plot the magnitude response and phase response both. Here you can see the graph of the phase response, frequency response. Now moving toward the task 6, in which we have a following digital transfer functions, in which we are plot the poles and zeros on the z-axis, and then we use the functions frequency to plot the magnitude, frequency response and phase response for each transfer functions, and then we identify the corresponding filters type: low pass, high pass, band pass and band stop. And then first we define the numerator and denominator coefficients, and then we create the transfer function object. After this we are plot the poles and zeros, and then we calculate the frequency response, and then we are plot the magnitude response and phase response both. After this we are getting the output of this. Here you can see the magnitude, phase, frequency response graph and phase frequency response graph, and you can see the poles and zeros of this task. Now moving toward the task 7, in which we are following a feedback filters, and we determine the locations of the poles and zeros, and then we plot the positions in z plane, and then first we define the filter coefficients and then filter coefficient 2, and then we create the transfer function object. After this we are plot the poles and zeros for filter 1 and filter 2, and then we compare the result. After this we are getting the output of this. Here you can see the poles and zeros, and then after this we are compare the result of poles and zeros both. In task 8, we determine, in which we also determine the poles and zeros of the following filters. First, filter 1, filter 2, filter 3, and then we also determine the poles and zeros. The degrees of the numerator denominator polynomials are different, so we should be the zeros at 0 to infinity. Here you can see the output of this task. Now moving toward the task 11, in which we have a frequency response of the design digital filter, for example 8.7, and we are giving a source code in which we are designing the analog filter, and then we convert to digital filter using bilinear transformations, and then we plot the magnitude and phase response. After this we are creating a new figures for phase response. Here you can see the parameters of this task, and now you can see the output of this code. Here you can see the phase response of Butterworth low pass filter, and you can see the magnitude response for low pass filter. This is all from my side. Thank you very much.